What's up, guy? Welcome back to Concrete Man Hawa channel. Today we're going to talk on slump test. So what is slump test? Slump test is used to evaluate the consistencies of fresh concrete. It is normally used indirectly as a means of checking the correct amount of water that has been added to the concrete mix. So there are a few standard of practice that we can refer to for evaluate and also to carry out the slump test, such as ASTM, American Standard of Testing Method C143, Astro T119, and British Standard 1881 standard of testings. So the diagrams here shows the apparatus for slump test. The apparatus consists of slump cone that's having a dimensions of internal diameter 100 mm at the top, internal diameter 200 mm at the bottoms, and a height of 300 mm. And the slump cone is going to be filled with freshly mixed concrete, and it is tamped with a tamping bar in a 3-layer manner. The steel slump cone is placed on a solid, impermeable, and a level base. So what are the procedures in conducting the slump test? Step number 1. You need to mix your concrete. If you don't know how to design your concrete, please refer to Laboratory 1 DOE design. If you don't know how to mix your concrete, please refer to Laboratory 2's concrete mixing method. So after you have mixed your concrete, when the concrete is in a fresh stage, you need to fill in the slump cone with your freshly mixed concrete. When you fill in the slump cone, you need to divide into 3 layers, and you need to do a tamping on each layer for a total of 25 times by using the tamping rod as shown in the videos. So once you have tamped for the top layers, the last layer, you need to level the top surface so that the whole concrete are fully according to the dimensions of the slump cones. After everything has been set, lift up the slump cone slowly, steady, and in vertical directions. So by right now you can see there is a subsidence happens on the slump, and the subsides is the slump loss. So you need to measure the slump drops. Okay, measure at the lowest slump loss that happens on your concrete. So this is the slump value that we use in our DOE design. Check with the slump values that you determine before you do your concreting. Make sure it is in the range of the slumps values that you have determined during DOE design. There are 3 kinds of slumps: true slumps, shear slumps, and collapse slumps. So when the cone is removed, the slump may take one of the 3 forms. In a true slumps, the concrete simply subsides, keeping more or less to the shapes that according to the cone. In a shear slump, the top portions of concrete shear like this and slip away, while in a collapse slumps, the concrete will eventually collapse completely. So like this. So to measure the slumps values, we have some indications for the slump value that you measured. For example, for the slump value 0 to 25 mm, we consider the degree of workability as a very low, where the applications of the slump value is shown on the last columns, where for a very low degree of workability, it can be used for a road vibrated power operated machines. Okay, it can be very light used in the road making. And for a slump value 100 to 170 mm, it is considered as very high workability. While for high workability, the application is for highly workable concrete for sections with congested reinforcement, not normally suitable for vibration. So usually when we are doing high slumps concrete, we don't do any vibrations anymore because it is normally a self-consolidating concrete. So to show you and to compare you how the effect of low workable and high workable concrete have a look on the videos. So the videos here shows you the low workable concrete. It needs a lot of workers to work with the concrete, and the concrete is very ugly after you work with, and it needs a lot of works to covering the concrete so that it looks very smooth and steady. However, if you are using high workable concrete, have a looks. High workable concrete, it can flow to all the corner by itself because of the high liquidity of the concrete, and it still needs a lot of people, and a lot of people just stand beside and have a look and observe the whole process. So this is high workable concrete, and high workable concrete eventually it will give you a very smooth surface, and it will give you less bubble, and it will give you more dense and more durable, more strength concrete because of this ability of consolidating through all the corners and congested reinforcement. So to conduct our slump test, there are a few precautions for you to take notes. For example, first one, to reduce the slump cone surface frictions by moisturizing the molds and the base before the test. So we need to make sure that the mold surface is as smooth as possible so that it won't affect the result of the slump. Make sure the molds and the base plate are non-porous because it will affect the slump loss later, and avoid nearby vibrations or shocks because it will affect the workability values if there is a vibrations or any compactions during ongoing beside the test. Make sure the concrete is very fresh, avoid delay, and complete the test right after your mixing. So that's all for today's slump test. Thank you very much. If you like this video, please subscribe and click on the bells, okay, and you will get an update from the YouTube. Thank you very much. Have a nice day.